And today's learning target is brought to you by Ivy and Arlo Kitties. Okay, team, 7.2. I can solve expressions with cube roots. Alright. Now, to review cube roots, it's going to help for us to remember what a cube actually is. And it starts with this thing. It's actually called a rectangular prism. I sketched one here. Feel free to sketch your own if you'd like. Maybe you can make yours look a little nicer. Anyways, a prism looks like this. To find the volume of a prism, we'd say volume is length times width times height. Be the volume of a prism. Now, if it's a cube, then the length, width, and height are all the same thing. I'm gonna do my best to sketch a cube here. Freehand. Now, if it's a perfect cube, the length, the width, and the height are all the same. We just call that S usually. S, S, S. It's all the same. So then the volume is S times S times S, which is the same thing as S to the third power, which is why we often call numbers, when they're to the third power, we call that cubing them, cube. So here we could think about a cube with the edge length, or a side length of 1. Well, 1 times 1 times 1 is going to give me 1. Now if that side length is 2, then the volume of the cube would be 2 times 2 times 2 again, which is 8. 3 times 3 is 9, times 3 again is 27. 4 times 4 times 4 is 64. Now I'm going to cheat and go to my calculator now. Feel free to pause and skip to this being done if you want to finish this quickly on your own. And last but not least, 15 to the third power is 3,375. Okay. So this is what we call perfect cubes, just so you know. We call all these numbers perfect cubes, and they get bigger a lot faster than the perfect squares do, you'll notice, okay? Alright, so now I'm going to go back to my notes here. So let's pretend the volume of this cube right here that we're given is 343 cubic inches, okay? And if I asked you to tell me what the side length is, well, you could either just think of a number that when it times itself again gives you 343, or you can just skip to your list of perfect cubes, okay? So the side length, we say, is equal to the cube root of 343. So instead of square roots, I use the same little radical symbol, but I put a 3 there to denote I want the cubic root. I want the number times itself again. So I can go to my list of perfect cubes here and I'm gonna check, I'm gonna look for that. Oh, 343, there it is. There's the volume. The side length would be, I'm skipping all the way here, is 7. So the side length here would be 7 inches long, is the trick. Okay, and now I have a few practices here. So that 3 tells me I want the cubic root of 27. Well, if I'm doing that, I'm gonna go to my list of perfect cubes here. Dun 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 dun. Oh, there it is. So I want the side length is 3. So this is 3. Okay, now it's a fraction. Well, I can either reduce this fraction or I can check to see if the numerator and the denominator are perfect cubes themselves. So let's check 1. Is 1 on my list? You're dang right it is. There it is. That is a side length of 1. Is 8 a perfect cube? Well, you're dang right it is. There it is. The cube root is 2. This is 1/2. Very interesting. And I could just do a little check. I could check by going 1/2 times 1/2 times 1/2. Make sure I get 1/8. 1 times 1 times 1 is 1. 2 times 2 is 4. Times 2 again is 8. So that works. Okay. Cube root of a negative 125. Well, if I'm finding a cube root of a negative number, whatever my answer is must also be negative. Okay, and let's check. It's 125 a perfect cube. Dun 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 dun. Oh, there it is. Cube root is negative 5 here. All right. Now we got some expressions with cube roots in them. I'm just going to remind you that we solve these expressions and or equations following the order of operations known as PEMDAS. Cube roots and square roots, these are like exponents, so I want to do them in that order. So almost always, I'm going to do them first after parentheses. Okay, so cube root of 216, better check to see what that is. Cube root is 6, so I'm going to rewrite this expression showing all of my steps. This is 2 times negative 6 minus 3. I'm still following the order of operations here. Better do my multiplication next. 2 times negative 6 is negative 12. Negative 12 minus 3 more is negative 15, and there is my answer. Go ahead and pause and try to do the next problem on your own. Okay, now that you've given it your best shot, here's what I'm doing. I'm going to evaluate the cube root first, 512. The cube root of that is 8. This is 100 minus 5 times 8. 5 times 8 is 40. 100 minus 40 is 60. Good job. Thanks for playing. Okay, and the last kind of problem that you might see are questions where you have an expression with a variable in it, and then you're told what that variable is. Now, this is really the same drill that we've been doing, except for I have to first make the substitution. So anywhere I see x, I want to change that to this number, 192. And feel free to pause so you can write all this down if you need to. But I'm going to take this 192, and I'm going to plug it in for x here. Okay, so instead of x over 4, I'm going to change that to 192 over 4. And instead of the cube root of x over 3, I'm going to change this to the cube root of 192 over 3. And then I'm just following the rules of PEMDAS, just like I've been doing. So let's go ahead and take care of the cube root here. Well, cube root of 192, let's check. It's not here. Okay, Well, if that happens, try to reduce this fraction first. Try to reduce this fraction. So I'm going to change this to 192 fourths plus 192 over 3. That reduces to 192 divided by 3. That reduces to 64. Now, I know what this is. I know that's a perfect cube. It's got a side length of 4. Cube root of 64 is 4. Now, I'm also going to reduce this fraction here. Well, let's go ahead and change that to 4 here. But let's reduce this fraction too. 192 divided by 4 is 48. So this is really just 48 plus 4, which is 52. Okay. Okay, now here's a fun, challenging problem, and team, feel free to pause and try this on your own if you would like, and then push play and see what the answer is. Test yourself. But piece of information that was missing here is that the volume of this baseball display case is 125 cubic inches, and I want to know the surface area. Surface area is the area of every single square face that covers this baseball. I want to know the whole thing. Well, to figure that out, first I need to find just the side length of this cube. So I'm going from volume all the way to side length. I'm taking the cube root. In fact, I might even say here S equals the cube root of 125. Well, the cube root of 125 is 5. So the side length here is 5. Now to find the surface area, I first have to find the area of just one square face. So this square face right here is just the side times the side. We're just finding the area of the square. 5 times 5 is 25. So one square is 25 inches. And how many squares are on a cube? Well, there's 1, 2, 3, 4 all the way around. And then there's one on top, one on bottom. There's 6 total faces. So I'm gonna multiply this times 6 square faces. 25 times 6 is 150. So the surface area is 150 square inches. Thanks for playing.